The exams were okay. In my opinion, there was a discrepancy in a couple places about what I said was effective annual versus the I-12s and I-4s with the little parentheses up at the top. There were some places where people used interest rates in a different way than I had thought. And I just kind of went back to the textbook and double checked to make sure that, no, that's what you do when you have the little 12 or when you don't have it. So if you've got questions, please come talk to me. Most of the time when that issue came up, I was fairly moderate in what I took off. I'm like, oh, that's only a change in the way the interest rate is used. Everything else you did follows what I wanted it to be. I'm very happy about that. Almost all of these are roughly based on the books out of the problems out of the textbook. There were a couple I stole from Dr. Burns. There was one where there was a deposit of 100 every month and deposit of 1,000 every year. And one of those was an annuity due, and one of those was an ordinary. Some people got that, some people didn't. But then the interest rate changes because if you're doing a monthly deposit, you're doing monthly compounding on an effective annual rate. If you're doing an annual deposit, you're doing an annual compounding. So we use the same interest rate two different ways in that problem. Again, if you've got particular questions, please come talk to me. I'm more than willing to negotiate and talk about this exam. Meanwhile, I want to keep talking about bonds. Frequently, we think of coupon payments from a bond as the interest payments. It's what we're earning for the deposited value of the bond. Well, I pay taxes on interest. So if I want a tax on a coupon, I need to know how much of that is principal versus how much of it is interest. So if I think of the bond as an amortized loan, and then the buyer is the lender, and the seller is the borrower, then the loan amount is the purchase price. Provided I use the yield rate, not the coupon rate, the yield rate as the loan rate. But let's think about the payment schedule. Because you buy a bond, you pay a purchase price. There's my purchase price right there. And I'm going to get coupons until here. So all of these payments are coupons. Face value times the coupon rate R. What's my last payment? If I think of this as a loan being paid back, what happens at the end of the bond? I'm sorry? It's all paid back. So I get a coupon, but I also get the face value back. So I end up with a different payment here. This is the downside to a bond payment because it's not level payment. I like level payment annuities. Level payments are easier, but this one isn't. So it's not level payments. If I think of this as a loan and that I want to try and amortize over time, I need to bring these back to the payment price. So all of these need to be brought back to whatever point in time I'm looking at to figure out how much more is left outstanding and how much I've already paid so I can talk about the taxes on it. In a loan, we had the amount of interest paid at each time and the amount of principal repaid at each time, right? The last question on the exam was about an amortization schedule. And it asked you to find I of T and PR of T and things like that at different points in time. If I think of all of these, let's pick a period I want to be brought back to, period T. I need to bring all of the periods that are still to come back to here at the yield rate J. Prospective form of all remaining coupons and the redemption value. That's what I want to compute right after the coupon is paid here. That'd be a present value calculation. And if I do that present value calculation, that's called the book value of the bond. At time t. This replaces the OB, the outstanding balance idea in my amortization schedule. Page 219 in the text. Our outstanding balance becomes the book value after the payment. We have a payment made, interest, and principal. Now, I must tell you, getting these formulas took me a little bit of work, but I'm going to think of the book value as the previous book value multiplied by the interest. Well, our interest rate's the yield rate, that's J, and then subtracting off the payment. Outstanding balance minus payment tells me how much interest I have. So we end up with a couple of specific formulas. I'm going to put a bookmark back on page 219 so I can get back to it. My starting balance, PV0, sorry, BV0, the book value, is the payment price. But our payment price, back in the previous chapter, was calculated explicitly. This is the prior value of the redemption amount and the amortization, bringing back in time all of the individual payments. Now, the textbook simply presents these formulas as a fiat. Here you go. I looked at this and I wasn't quite sure where they all came from. So me being the algebraic geek I was, I went through and figured out BV of 1 directly from BV of 0. But that's figure out the interest and do all the subtraction and simplify as much as possible, which was not pretty. But this is the result that's on page 219, is that we combine these three formulas to get this schedule. But rather than just go through pile after pile after pile of algebra, let's do one. Let's take a bond whose face value is 10,000 with a coupon rate of 10% that matures in 4 years. I need two pieces of information to get to the final place without this. I need to know what the yield rate is. And then I need to know the coupon frequency. I'm going to make the assumption these are semi-annual coupons. If the yield rate is 8%, then what do I get? Well, remember, these are annual rates. If I'm couponing semi-annually, then this is R is half of that. R is 0.05. If the yield is 8%, then J is 0.04. Um, what's the present value for this bond? BV0, the starting book value. That's the formula right at the top of this page. So let's work this out. My calculator. What's N? Great. So I need this number. 10,000, 1 plus 0.01, 1 minus 1.04 to the negative 8 over 0.04. Before I go any further with this calculation, is this number bigger or smaller than 10,000? Because we're adding something. This makes sense. My yield is lower than my coupon. They're paying me 5% every 6 months, but they're only able to earn 4%. I'm going to have to pay extra for this. So this is a bond bought at a premium. A little bit of calculator work. Crunch, 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 crunch. It's above 10,000. 10,673.27. Okay. My payments are the coupon amounts. So this is the book value at time 0. That's the number that goes here. A period later, we'll have another book value, but I'm going to calculate it this way. We'll make a payment. Some of it will go to interest. Some of it will go to principal. I'm going to make my first payment. What's my first payment? Right. because I've got a $10,000 bond and it's paying 5%. Now, the amount of interest is the book value times the yield rate. So that's 4%. So I take this 107, 106, 7327, multiply by 0.04, and that's the amount of interest I pay, which is how much? The difference is 73.07. So I take this amount, subtract it off, 10600.20. That's my new book value. This is the part of the way they've organized this table that bothers me. I think book value should be the rightmost column, not the leftmost column. But I didn't get to write the rules. I didn't write the way the table was written out of the book. All I've used are these three formulas. But I didn't really use this one very much. I just said, oh, well, I take the payment off after I multiply by the interest rate. I did this in Excel. Now you'll notice this time we came up with a slightly different number for that first balance line. And I did put the book value on the right instead of on the left. I like doing this. I want to share this so it shows up in the recording. I knew I forgot to do something. Share. There. Now we can see the whole thing. So, a non-level payment. Notice what happens. At no point does the book value go below 10,000. We paid a premium. We paid extra to buy this bond. We paid $673.27 extra to get this bond. And the amount of interest allowed me to pay down that premium. So at the very end, I give you your coupon, which pays you the interest, and I give you the face value, and the balance is exactly zero. Here you go. We laid out even. If I need to write down a premium, write down a bond in general, this is what's going to happen. But I didn't say you can only buy bonds at premiums. We bought this particular bond with a yield at 8% and a coupon rate of 10. The coupon rate being higher is why we paid the premium. What did we call it if they're the same? If the yield rate and the coupon rate are exactly equal, we're buying our bond at par. If that's the case, then my face value calculated here will have 0.05 minus 0.05, right? This whole thing will be zero. And the face value and the book value will be the same. And notice that if I set the interest rate and the yield rate both to be 10%, the amount of interest I get to earn in a 6-month period is exactly the value of the coupon. I made $500 off the interest. Here's your $500. Book value stays $10,000 all the way down the line. At par. The entire time we're doing this, the book value stays the same. What if the yield rate is the higher one? Well, then I can earn more money than the coupons are giving me, which means I'm going to pay less because in the formula back here in the paper, this number would be reversed. And I'd be subtracting something, which means I buy my bond at not a premium, at a discount. But then the book value is lower. If the book value is lower, then I'm earning more than the coupon, right? That means I have to build up the book value so that at the end of the 4 years, I have $10,000 to give you. So in this case, the excess principal from the interest is what's making up the discount. So we write down our premium, we write up our discount. If I believe I can earn more money than the coupon rate, my yield rate is higher. The discount I offer you, I have to be able to make up the money somewhere. And that's what this amortization schedule shows me, is that I can write up the bond. And that's called capitalizing interest. I take the excess interest, turn it into book value. I turn it into capital, into cash in hand. In this case, cash that goes towards the value of the bond. So this principal repaid amount is increasing the value of our bond. It's the amount for accumulation of discount as opposed to the amortization of premium. Now, rather than write this by hand over and over and over again, I don't want to deal with this thing being rewritten every time. I'm going to do this in Excel as often as I can get away with. If yield rate varies over time, this can be done with an integral, but it's a major pain in the ass. So it's almost always easier to do this as an iterative process discretely rather than try and do it in one fell swoop as a forecast, because you then have to know the function of what you think the yield rate's going to do. I'm not that good at predicting the market. I think the market's crazy right now. Questions? For a large number of market funds, the declarations of book value is how they declare taxes. It's how they declare the value of the funds overall rather than face value, because they look at what's still outstanding to be earned or to be paid back, depending on whether we're looking at discount or premium. A bond is callable if it has a range of redemption rates, dates. Now, those dates are negotiated between the buyer and the seller, but they're almost always chosen by the seller. And the price depends on the length of time to redemption and the yield for any given price. Pricing, though, will then need to cover all the options for redemption time. Okay, what the hell? Again, this is a case where I've got to figure the price, the formula we already have for price. But the formula now is going to change because I'm going to allow myself more than one choice of n. The bond we were just looking at was redeemed after 4 years, right? But I could just easily say you could redeem this bond anywhere between 4 and 6 years. Well, that would give me n equals 8, 9, 10, 11, or 12, right? And I'd have to know the price for any of those to figure out what the payment would be. The example in the text has a face value of $1 million. It says we're going to do 10% semi-annual coupons. And redemption at any coupon date between 12 and 15 years. Now I'm being specific here. I want to redeem on a coupon date as opposed to between coupon dates. I don't have to deal with that extra part of a period. And now it asks me to look at two different yields. Again, whichever one I look at, I know right now before I do anything else, which one of these sets of numbers will be below and which one will be above $1 million. Which ones will be above $1 million? 12% or the 8%? Because exactly. My yield rate is lower than my coupon rate. I'm getting paid more than they think they can earn. I'm going to pay a premium. So these numbers will be above $1 million. These numbers will be below $1 million. This will be at a discount. This will be at a premium. Now, the problem is from a calculation standpoint, this is boring. I'm really going to do the following calculation a lot. I'm going to do P equals 1 million, 1 plus 0.05. Why 0.05? Exactly. 10% semi-annual means a 0.5 R, 0.05 R, minus J. Well, J is either here, J is 0.06, here J is 0.04. And then I'm going to do A, N, J. But what are my values of N? Ah, not just or 24 or 30, but all the ones in between. Which means I have to do this calculation 14 times. Oh, joy. Rapture beyond compare. All right, hang on a second. Here you go. You can see exactly the formula I did. The face value is up in B1 in that top cell. 1 plus R minus J. And then the AN is here. 1 minus 1 plus J to the negative number of periods divided by J. That's our ANJ calculation. Now, if I want to guarantee a yield of 12%, that's the left column. If I want you to tell me you are absolutely going to get a minimum of a 12% yield, you should offer the lowest price in that column. And in this case, because this is at a discount, the lowest price is the furthest one in the future. Because the further forward I go, the more I'm taking off as yield behavior. Similarly, at a premium, if I want to guarantee myself 8%, I should offer the lowest price, in this case being the first date. If I've paid a premium, the lowest possible premium I can pay is earliest. All right. That's my position as a buyer. As a seller, what do I want to do? I want to charge the highest possible price for the yield I'm expecting to earn. So let's figure out what the actual yields are. Suppose this is in our Excel examples, but I'll come back and forth to this for a minute. Suppose that the seller wins. But they redeem at the lowest price N. So let me think about this for a second. Do you want to do the 12% or the 8% to start with? Okay, so at the 12%, I go back to the Excel sheet. At 12%, the highest price was here. $874,496.42, but I want to redeem at n equals 30. Okay, but I'm redeeming at the face value. So I get 874,496.42 equals 1,000,000. 1 plus 1 plus, sorry, 0.05 minus J here is 0.06. A 30.06. Oh, no, wait a minute. No, scratch that. It would be if this was the same. This was for 24, but this is 30. I don't know the yield. The yield is the thing I'm trying to find. That's got to be J. Now, this is the problem because I don't know how to solve this equation by hand. So instead, what I'm going to do is I'm going to divide by the million, and I get 0.874499642 equals 1 plus 0.05 minus J, 1 minus 1 plus J to the negative 30 over J. And I can do a bunch of algebra here, but I don't think it's worthwhile. So let me grab my calculator and graph this sucker. So I'll start by graphing this number, 0.874499642. And then I'm going to graph all of that garbage. 1 plus, parentheses, 0.05 minus x times 1 minus, parenthesis, 1 plus x raised to the negative 30th, close those parentheses, divide by x, close those parentheses, right? Do I have the right number of parentheses? 1, close, 1, 2, closed, 1. Oh, I have one too many sets of parentheses. Let's delete that one. Okay, good. Now, this is going to give me a yield rate, right? Yield rate should be in the decimals. I really don't need to look at giant yield rates up near 100%. So I'm actually going to set my window to be really small. My window is only going to go from 0 to 0.25. And my y values are all between 0 and 1 because I divided out the million. So I really don't need anything bigger than that. And now if I graph this sucker, there's that left-hand side, and here comes the right-hand side. Hey, there's my yield curve. And that's the yield curve I keep expecting, right? The yield curve that comes down and is concave up and asymptotic to the y-axis. Sorry, the x-axis. Where do those intersect? 5. So I get an intersection of let's call it 0.059. That's J. Which means my yield is twice that, 11.8%. So in spite of the fact that I thought we negotiated this at 12%, by redeeming late, actually earn a little less. I paid more, and so my actual yield was a little lower. Now this was for the 12% bond, which was at a discount. What if I'm doing the bond at a premium, at the 8% rate? .08. Well, now I go back to the Excel sheet and I notice that the highest price is at this time, but I would redeem at the lowest price N, which is 24. So I have a price of 1,172,000 920.33, and I redeem at 24. Again, same calculation idea where I'm solving for J, 1172920.33 equals 1,000,000, 1 plus 0.05 minus J, A 24J. So the seller got their way. We paid the highest possible price, but we're redeeming at the wrong end of our price options. Again, I'm going to divide by the million. Now I'm going to need to change my window a little bit because when I divide by the million here, I get 1.172920033. So my number is a little bit above 1 rather than just below 1. This is the same as up here, the 0.05 minus J. It's this number that changed from 30 to 24. So in here, I'm going to go out to where that exponent is and change it from 30 to 24. And again, if I go back and change my window so that I can see what's going on, there's my value. What's happening this time? Remember, our yield was going to be 8%. So R would be 0.04. But this time, because I'm at the wrong redemption rate, my yield is again low, 0.03388, which gives me an effective yield of 7.76. Now, this is what happens if the seller wins. They charge you the highest price possible. What if the buyer wins? Let's do two more calculations. What happens if I pay the lowest possible price, but redeem at the time for the highest price? Let me go strip the data off of my Excel sheet. So the time and the lowest price, but the time with the highest price. So for the 12%, the price, the lowest price on the 12% line is 862, 351.69, but the time with the highest price is 24. In the 8% column, the lowest price is 1152469.63. That's the earliest, but we're redeeming the latest. So I just switched the two options here. Do the calculations this time. Started writing too far over. I'm doing the same two calculations, but I've switched the numbering when I'm redeeming. So in this case, where my bond was issued at a discount, I'm at the 24 months, sorry, 24 periods time. Well, that's the time we were just using. So I'm going to do that one first. What do I get for a yield? What's my yield in this option? Because I get 0.061 here, but that's J. And the yield doubles that, so 12.2%. Hey, wait a second. We paid a lower price, held it to the short end, and sold it. We earned more than the 12% where that price was calculated from. If I want to do this one, 1.15246,963, and now I change that back to 30. Now, I bought this at a discount. But I'm holding it longer. I should earn more. Lo and behold, my yield is my J is 0.041. So I get a yield of 8.2% as opposed to 8%. So when I pay the lowest possible price and I hold longer, I earn a higher yield. If I pay the highest possible price and hold shorter, I earn shorter, a lower yield. But the seller determines the call date, not the buyer. So the buyer doesn't always have the option of deciding when the bond gets called. Usually the seller does. The general rule, if I'm the seller, what do I want to have happen with my yield? Seller's the person borrowing the money. I want to pay a low yield. So my goal is to minimize the yield, but I almost always want to find the price with at least a given yield. In general, to find P for a yield of at least J. If I'm the buyer, I want to set the price so I know at least I'm going to get the yield I want. If I'm buying at a discount, price less than redemption value, which is the same as saying that R is less than J. My yield is high. The minimum price will occur at the latest possible N. Because if R is less than J, I'm subtracting. And the further out I go, the more I discount. If price is bigger than redemption, equivalent to R being bigger than J, a premium price, then the reverse is true. The minimum price occurs at the earliest possible N. If a fixed price is given, so I didn't do an example like that, but I could say, what if we paid 900,000 for this bond? What's our yield? Let's assume it's a discounted price. So I give you, I just said 90,000. That's a discount from the 100,000 face value. Sorry, from the million face value. Then what happens at the end is I get more than I put in. That's a capital gain. So when we talk about capital gains tax, this is the same idea of what we're talking about. And that means the sooner we get it, the higher the yield. What's the reverse situation in a discount, in a premium bond? What would I get on a premium bond? Exactly. And if I get a capital loss, then the sooner I get it, the lower the yield. Now, why would I be willing to take a capital loss? I'm offsetting something else by making this sale quick, right? So if I take that loss, that must mean I'm using that loss on the books to balance some other gain I made somewhere else. If I play this game right, I can adjust on my book value the value of my bond holdings. Again, as a bookkeeper for a company, this is a good idea to me. I pay taxes on capital gains. I deduct from my taxes for capital losses. If I realize a loss, I take a tax benefit. So there are times when my company makes money in lowered taxes by losing money in value. So if on paper I can say we lost money this year, I don't have to pay taxes, or at least I don't have to pay as much taxes. Now, yields change over time. And that means the seller, that's the one who has the call power, the seller, the issuer, has the option to call in the bond. And issue a new one with the same face value to get a better deal. If a yield is 9% at time 12, then excuse me, a new bond has a different face value. We were just dealing with a bond of $1 million, right? If yield is 9% at time 12, then a new bond due at time 15 has a price of P equals 1,000,000, 1 plus, all right, wait a minute. The premium bond. The yield was 9. We were paying 10. So that's R minus J. 0.05 minus 0.045. A be 6 payments at 0.045. What's this value? $1,045,789.36. Hey, wait a minute. The face value of $100,000 was the same face value as on the other bond at a yield of 8% or at a yield of 12%, right? If the yield changes and now it's 9, I call your bond. I call you back and I say, bring back the bond. I'm going to give you $100,000 right now. But I do that by issuing this bond. So I go to somebody else and I say, hey, person, will you buy my $1,000,000 worth of debt? Will you loan me $1,000,000 at a yield of 9%? I'll pay you 10% on coupons every 6 months. And if you say yes, you give me $1,025,789. But remember, I have this other outstanding bond, so what do? I take $1,000,000 of that and I pay off the other bond. I just made 25 grand. All of this is working off the assumption that our called bond, this one tight, is called at face value, at par. But redemption value doesn't have to be face value. I could issue a bond whose face value is 100, whatever, and say, if you redeem it at year 10, it'll be 100. But if you let me hang on to it a little longer, I'll let you redeem it at 115. If you let me hold on to it a little longer than that, I'll let you redeem it at 135. So if I change my redemption value based on time, then there might be a different story about when the right time to get this bond back is. I have 3 minutes. That's not enough time to work through the example I want to do. So we'll pick up this example on Thursday. And we'll see you all then. Have a wonderful rest of your day.